Now moving towards another important function, which is actually formative and remodeling function of the periodontal ligament. So let's start it. Bismillahirrahmanirrahim. So basically, the pedial and alveolar bone cells are exposed to physical forces. Means these pedial and the alveolar bone is actually exposed to different type of forces like masticatory forces, para-function habits like bruxism, clinching, speech like during speaking, or orthodontic tooth movements. Okay. Cells of the pedial participate in the formation, resorption of cementum and bone. So basically, the pedial actually play a role in the formation and resorption in the cementum bone, which occur during the physiologic tooth movement, during the accommodation of the periodontium to the occlusal forces, and during the repair of the injuries. What happened that during the remodeling process, it is related to the cellular enzyme activity. Okay, when load is applied, so it induces the vascular or inflammatory changes. These changes occur in the pedial cells and suggest that these cells have a mechanism to respond directly to the mechanical forces by activation of various mechanosensory signaling systems, including adenylate cyclase, stretch activated ion channels, or by changes in cytoskeleton organization. So they are saying basically the enzymes have a huge role in the remodeling process, and when the force is applied, so basically they induce vascular and inflammatory changes in the pedial. So the pedial cells actually responds directly by activation of the mechanosensory signaling systems like adenylate cyclase, stretch activated ion channels, or by cytoskeletal organization. They are saying that cartilage formation in pedial, although is not so much common, but it represents a metaplastic phenomena in the repair of this ligament after injury. The pedial is constantly undergoing remodeling process, means it is constantly remodeled. Old cells and fibers are broken, they are replaced by new ones, and mitotic activity is observed in fibroblasts and endothelial cells. We know that fibroblasts basically form the bone. They are the cell forming bone forming cells. Fibroblasts form also the collagen osteoblast actually forms the bone. So fibroblasts we know form the collagen fibers, and their residual mesenchymal cells develop into the osteoblast. Then and also cemento. So the fibroblasts then convert into osteo and cementoblast. Therefore, the rate of formation differentiation of the osteoblast, cementoblast, and fibroblast affect the rate of formation of collagen, cementum, and bone. Okay. Now, radioartographic studies also suggest studies is like radioactive thymidine, proline, and glycine indicate high turnover rate of collagen in the pedial. Means they say that thymidine, proline, and glycine has a high turnover rate of the collagen in the pedial. The rate of collagen synthesis is 2 times fast as that of the gingiva and 4 times as fast in the skin. There has been studied in the rat molar. The rapid turnover of sulfide glycoaminoglycans in the cells and the amorphous round substance of the pedials also occurs. It should be noted that most of these studies has been performed in rodents, and their information has been pyramids and humans in scars. So basically, there's a constant remodeling process occurs in the pedial. Okay, and fibroblasts is form the collagen. The remaining are converted into the osteo and cementoblast, and then their differentiation and formation actually affect the collagen and cementum and bone turnover rate. Okay, simply.